As I was just we talk about that Sentinel-1 SAR for prop types, prop type analysis. Okay, so for that, first of all, it's basically we find out this VV and VS polarization, and it's very sensitive to probe structure, to probe structure, also biomass, and also soil moisture. We can easily identify, okay, using the VV or VS. And it's a high frequency. This is another benefit. I revisit frequency. Okay, basically in the 6 to 12 is 12 base. Okay, and another very powerful is that it's penetrates clouds. So this is the best benefit to use the Sentinel-1 SAR data. Ideal for monsoon or cloudy region, you can easily use it. Okay, and we can also use it to make your time series of phenology analysis, and also classification and crop mapping. This type of things we can easily use the Sentinel-1 SAR data. So let's go. First of all, we need to define our study area. So take a variable, suppose AOI. Suppose I have a rectangle, latitude, longitude value. So I want to import. Okay. So for that, you can simply use the geometry dot rectangle. It's not work right. dot geo. Okay, let me check the function.
Small g. Case. It is no case.
Okay. Geometry. Okay, just a minute. Okay, I think I need to reload this site again. Just a minute. It's not connecting the server, so that's why function is not showing the purple color. Just a minute. So take a variable AOI dot now you can see it. Okay, yeah, dot rectangle. So now we simply define a list. Now I take the 89.0, then 23.5, longitude, latitude, then put the longitude. So it was 90.0, 24.5. So now let's check. We try to show our study area. Map.at layer UI, and of the focus map.center object. Object is AY, and run the. So this is our study area, suppose. Yeah. So for this area, we want to identify crop types using Sentinel-1 SAR data. So now further simply call the load the image collection. So for that simply copy this snippet ID and paste, and then give a name. Suppose I put the name is S1, and then filter for our study area. So for that, just take a variable. Suppose put the filter bounds function with my study area, which is AOI. Then put the filter date. So I put the time. Suppose cropping season. Okay. Suppose 2023. 06/01 from 2023 10/01. So cropping season. After that, I want to simply filter the instrument mode. So just I put out the filter and put here earth engine filter dot equal. So I want to filter in instrument mode. So instrument mode is instrument mode. Okay, and put at the IW. You can also get this type of information from here. Image properties. So we can see instrument file is instrument mode. Yeah, instrument mode. Yeah, so this one instrument, we can use the IW, interferometric wide swath, extra wide swath, and a strip. So it is the IW. Okay, so it's very popular. We use all time interferometric instrument mode. Okay, so after that we need to filter the transmitter receiver. Okay, transmitter receiver. Basically, we try to select the band. So for that, put here the dot filter, earth engine dot filter. And this time I want to filter list contains. So list contains, and I want to list contains. I just put the transmitter receiver, or check the bands. Image properties. You can check this transmitter receiver polarization. Then I put band name. I put VV. Same. Also do for the same for the VIs. Just I copy the same line of code and paste here, and I put here that VIs. Okay, transmitter receiver polarizer is set, and also put the your orbiting pass. Okay, orbit pass. So put here the filter again, and earth engine dot filter dot equal. I want to put here orbit pass, orbit properties passed. You can check orbit properties passed. Yeah, this one. So basically ascending, descending. So I put the descending. Okay, descending. And finally, we simply click with our study area. Just clip. And in this case, you can see if I just use here the clip, it will be problem. You can see. Suppose I will show you the how many images. First of all, suppose print S1 and apply the size function and run the code. 36 images we find out. Okay, for this time. And I want to clip all of images. Okay, so in this case, you can see if I just put here the dot clip function and clip with AOI, it a problem. You can see we face a problem. Suppose I want to add the layer, so then it show a problem. Map dot add layer and call the S1 around the code. It show a problem. We find out this type of problem. Okay, so I want to clip all of images. Okay, I want to clip all of images. Suppose I have how many images? We check total 36 images. S1 dot size. So you can say how many images we find out. We find out total how many images? Just a minute. I find out total 36 images. So I want to clip all of images. So now what can you tell me what the function I need to use when I use the 36 image clip? Any idea?
So yes, we can use median.
No, in this time I want to, without creating median, mean, or without creating the composite, we just simply clip all of images. So I have total 36 images. I want to clip all of images without creating median, mean, or mosaic.
Yes.
So further, we just create a function. So in this time, I create a function. This function helped me to clipping all of images. So let's go try to create a function. So I want to apply the clip all of images. So we create a function. So I put the function, suppose function keyword, I put the function value name is that, suppose I put the name is img. And now what is my argument? My argument is that all of
Function
images.
name.
So for that, we simply take a variable. So I want to return this element clip with AOI. Okay, and this is my function. This function I connect with my collection, 36 image collection. For connecting, use here the map function. Yeah, please.
Function has no name.
Please.
The function created has no name.
Why?
Function any argument that function has no name. Maybe function.
No.
Function name.
In this
function
time,
name.
okay. So now we try to use the same variable name. Okay. So you can see the same line of code. We just connect with the same variable. So I create a function. So this is my function, and I just connecting with this same variable. Just use the map.
Okay,
So this thing basically stored my collection, 36 image collection, and this collection I simply connect with my function. So now you can see without clipping function, I can display my map. Okay, it show this type of map without, if you check,
without median.
Not median. So it's just show all of without composite. Yeah, without composite, we just clip all of images. Okay. So now further, if you check, suppose I want to check the band, specific bands, and then stressing, suppose 98%, and then apply. So now we find out this type of imagery from here. So this is the one process. Without creating mosaic, we can also use the clip function, but for that we need to help of function, because at the same time total 36 images I want to clip with my study area. So that's why we simply create a function. So now this image we need to pre-process basically speckle filtering. Okay, so it's called that speckle filtering. So let's go try to discuss about that, how we can easily filtering the image for Sentinel-2. So pre-processing the image.
Please.
Yeah, please.
We can also add we can also composite the 36 image and proceed with the
Yes.
It is possible.
Yeah, also same.
Okay.
Suppose after clipping you can simply apply dot median. So then it clipping all of 36 images and also create the median composite. Okay, and when you done the clipping, so then after creating the median, don't need to use the clip because you already complete this process for clipping.
Okay.
Yeah. Okay, so now we pre-processing the image. For that, we need to speckle filtering. Speckle filtering, or it also called the reduce noise, mainly reduce noisy pixel. Okay, and radiometric correction is already done. Okay, radiometric correction is not need. Radiometric, this calibration, radiometric calibration done, already done in GE. Okay, so it's not need. And also train correction, sometime it already applied. Okay, so but when you work with other, then need this type of correction, train correction we need, but this train correction already done in GE, so that's why not need to for the train correction. So now we are simply convert to dB scale value. Okay, so if you check the bands, so this type of bands value is simply convert into dV unit. Okay, so dV unit we need to convert this type of band pixel value. So speckle filtering and radiometric decibel, radiometric calibration done, already done, then train correction is already done. So now we simply applying the speckle filtering and also convert the dV scale. So for that, we just take a variable, suppose 2 dB, and then we just create a function. Suppose I put the function name is img and put the curly bracket. So for that, for the dV, normally we are just take the value 10. Okay, so I return, but this is another process for the speckle filtering. So I hope you can also learn about that flood mapping in our 7th number class. In the flood mapping, when I pre-process the Sentinel data, I try to add the full function for pre-processing the Sentinel-1 SAR data for the flood mapping when I discuss about that. Because flood mapping, when I discuss, then I discuss about that speckle filtering. Okay, very long code we need to add for the speckle filtering, but in this case, we normally take the value 10 and then convert the dV. Okay, so for that we simply put the return and ee dot image. I put the normal value 10, and these things multiply with image logarithm log 10, and after that apply the copy properties and apply all of images, and also image dot property names. Okay, so this is the function. This function I want to connect with my image collection. So I put the variable s1 and then call this collection. I put the same s1. I take the same variable s1 and then put the dot map function and connect this function variable and paste here. So basically the normally we just use. So now we can extract your different types of feature. Okay, suppose we need to extract some pixel value such as VV or VS or VB by VS ratio. Okay, VB by VS ratio. So for that, first of all, you calculate the ratio. Suppose VB by VS. So take a variable. Suppose I put the variable name is the ratio, and I call the S1. I create a function. Suppose for that function keyword, and I just I take the element image. So now what is my argument? My argument is that I want to compute this ratio. So for that, just take a variable. So I take a variable, suppose VV, and call the image and select the band of VV. Take the another variable, suppose VS, call the element name and select the VS band, VS, and then we simply return. What I return? I want to return this BV divide with VS. Okay, and then I rename it. Suppose dot rename. I put the name. This band name is VV and VS ratio. Okay, I put this type of name. And this thing I want to apply all of those images. So put here the copy properties, and apply all of images, and also mention image property names. Okay. So now it's a function. I just simply connect with all of images. This is the S1. Just take copy and connecting with my function using map function. Just put at the dot map and also close this parenthesis. So now you compute the ratio. Okay, ratio. And so now in this case, we simply put our training data. Okay, so in this time, suppose for this place, I have some training point. So this training point I want to import. If you want, you can also import the CSV file, no problem. And directly you can simply click on and import the CSV file, or if you want, you can also take the some point randomly, you can write, or also import the CSV file. Suppose I take a variable props. So this variable I just put all of props. I just create a feature collection. This feature collection I add some different feature of prop. So put here ee dot feature collection. Okay, so in this feature collection I want to set some feature. So first feature, so put here ee dot feature, and I want to create a point of latitude longitude. Put here ee dot geometry dot point. Okay, and I can put the latitude longitude value. Okay, suppose in this case I put the 89.5. Suppose I randomly put, but when you work you can just put the accurate data. So I put at suppose 89.5 longitude, then I put here suppose 23.9. So I point out this is the one crop, and I put the property. Suppose I said the column name is the class. Suppose this is the price. Okay, so same, I create the another, I put the same, copy this same line of code. So this is my training sample. Okay, so just I simply take the two training sample at this time, but if you want to get also more when you work with the practically. So I put this is the latitude longitude for 89.7 and 23 point, suppose I put the 8, and I put the class. Suppose this is the class for wheat. So then you can put the other crop, suppose rice, sugarcane, or different types of crop for, with the different. Okay, so this is my feature collection. Okay, this is my training sample for ground. So I just assigning the level for the different types of crop, so rice, sugarcane, or wheat. Okay, so now we simply stack the feature. Okay, suppose we simply create the median composite. So just take a variable. Suppose I put the variable name is composite and call the S1. Okay, and then apply the, I create suppose median, and I want to add the bands. So his band I want to create ratio. So this one I want to add. So for that, just apply a function add bands, call this ratio, and for this band I want to create the also same median. So put at the median again. So now let's check, we try to display. Oh my god, it show a problem, too many argument image dot compute the natural algorithm for the input. Okay, so I will try to show you the later for that proper way to compute the DBS scale. So now we try to compute the composite without DBS scale, and we find out this type of median composite. So just I simply and display. Original display suppose VS ratio. So we find out this type of visualization. Just import. Okay. Okay, and if you check our training sample from here, just add. Okay, so suppose this is the random training sample. We just put price and weight. So this is our training sample. But when you work, you take the more training sample from your CSV file or also take. So now we're simply applying the machine learning model and compute. And it also more better if you want to classify the other classes. Okay, same process. I already show you this process in here. So simply separate some other classes, suppose barren land, urban, water, forest, or grassland. It will be more better for the crop types classification. Otherwise, it also mixing. Okay. So now I'll show you that how we can easily apply. Okay, so for that we find out this is our composite imagery. Okay, so now we need to create the training sample. Okay, so we need to extract the pixel value. So take a variable. Suppose I put the variable name is training and call this composite. So from this composite, I simply store it the information using the sample regions function. Okay, and put here sample regions. Suppose collection. It's mainly your props, different types of props training sample collection, and then put here your properties. So set the property property is the class. Okay, because you can say I put the property name is the class, it's our column name. So after the property we need to set the scale is 10 meter. So further just print and check the training. So if we can check, we find out only two training sample. We just simply extract the pixel value. So if you check total 5 properties, we find out the VV, PS, angle, class, and also ratio. Okay, we simply add PS, VV, angle, class, and VS ratio for the two training sample. So this is my property. So I need to use this type of property and then apply the machine learning model and then further make the classification. Okay. So other process keep the same. Suppose for the same process, just simply apply, create the classification, okay, create the model, random forest or others, and then we simply apply. So let's go and try to show you that. So for that, I can simply get this type of SAR ratio. So let's go try to apply. So after creating the data set, further you can also spill the data. So split data set, okay, suppose 70% and 30%, okay, 70% data is for train and 30% data for test, same process, okay. So now I just try to apply the directly, I would try to apply the machine learning without spill the data. So you also try when you work with the main project, simply spill the data set 70%, 30%, and use the 70% data train your model and 30% data for test your model. So I directly apply the classifier or machine learning model. So I put e dot classifier smile random forest, and I put random number of trees, suppose 100, and then train. So I train all of data. So call the feature. Basically this is my training. Okay, but when you work with the real project, then try to spill the data 70% and 30%, and then just train, and then put add class property. I put the property name class, then put the input properties. Input properties basically it's our band name, and this band come from this composite, all of bands, okay, basically VIs, VV. I put here the band names, so it means that all of bands indicating this composite have VV, VIs, angle, class, and also at this type of thing we can simply add this type of bands, input properties as the bands. So these are classified, so simply connect with our image. So take a variable, suppose classified and call the composite. So this is my composite, and then connect using the classify function. Classify with the classifier, just copy and paste. So now further just add the map.add layer and display the result. Okay, classify and add the color. That was 0, and then max. Suppose. So we put the 2 class or 3 class. That was rice, then wheat and others. Okay. So we create this type of 3 class. Suppose I put the color plated. So then make the color. Suppose I put at the green color for the rice, and then wheat. Suppose I put at the yellow color, and others I put the blue color. So now let's check the result. It's a problem either. What's the problem?
So the class property is it found in the training sample, the data set. We have class property.
This one, yeah.
Yes. Do we have in the variable that we created?
Or we need to add the.
Yes. Class property.
Oh, it's a features. No. S. Okay.
Yeah.
Okay, I have to just class of feature 00 invalid property accepted floor type string actual will rise. Okay, so what's the problem?
affected.
Okay, it's work as a keyword. Suppose I put the, so I put here the, suppose level. Otherwise it work as a keyword. Class is the another keyword, suppose level, and I want to do all of those using the level. So level. Now, okay, suppose for the rice I set the level is 0 for rice, okay, and wheat for I set suppose 1.
Yeah. 1, yes.
So now I hope it will work. Yeah. So
No, that's wrong.
okay, so it show the color. Color is not valid CSS format. I think some mistake for the color. Oh, CR green, yellow color. Okay, so we find out this type of classification. Okay, but it's not the properly, so it's a demo. But when you work with real data, suppose when you add the all of data, suppose all of training sample, okay, then this code is also help you to generate. Yeah, but in this time we just only for, they can also take the other class for the water body, okay, because they are also have all the water, okay, and also take the all of training sample from the ground, from your ground truth data. Okay, then further you also try to compare your results.
So, sir,
yeah, please.
If now you don't have ground truth data, you are not, now it is impossible, it is difficult to use this Sentinel-1 image for classification of crops or any land use and cover, is it?
Yes. So in this time we are just using the ground truth data. Suppose this is my ground truth data. Okay, so this is my ground truth data. But this data I imported your manually. But this thing we also imported as a CSV file in here. But in this case, I put the manually and then run it.
Yes. What I mean.
So without ground truth data, it also possible to identify the agriculture type.
So now my question is, what?
Please. Cannot hear you.
How now can you? Yes, sir, I'm hearing you. Now my question is, if I don't have now ground truth, I want to train you. How can I identify that this is bare land or this is certain feature using this SAR image? Because in Landsat I can see by using maybe for Scala. But in this Sentinel-1, it is difficult to identify this is what or this is.
Okay, so for that you just simply use the same time period and take the multispectral data. Okay, use the same time period or also increasing or decreasing time period and take the multispectral, suppose Sentinel-2 data, and the Sentinel-2 data just combine and take the training sample from the Sentinel-1 data. Okay, so just add the layer for Sentinel-2. Okay, and then in the Sentinel-2 just use the different types of band combination and take the training sample from the Sentinel-1 SAR data. Okay, so we are just use the Sentinel-2 data set as a overlay with this map, and then we simply take the training sample from Sentinel-1, but we are just take the help of Sentinel-2 data, multispectral data.
Now what if now if Sentinel-2 is not available, maybe due to the clouds effect? Because one among the advantage of using Sentinel-1 is it is capable, even it is free from clouds. Now if the Sentinel-2's optical image has now affected by clouds, it is now impossible to use this, is it?
Yes.
So I must have the help of a multispectral image.
Yes. And you can also check suppose some visualization. Suppose you can see how we can easily get this type of place is the water body, or also you can see this type of black color. It shows a your trees. Okay, we can easily get some idea. or if you check, and you can also take the help of your satellite. Google satellite data also help you. So it can see it's a show the build up. Okay, we also take it this type of pixel show the build up. Okay, just use some reference image, Google satellite image, also Landsat Sentinel-2, and then help of them we can also get. Okay, as well as this Sentinel-2 we can also useful for your vegetation index. Suppose it's called that RVI. You can also use RVI, RVI index for vegetation, Sentinel-1. Okay, so Sentinel-1 is the it's called the radar vegetation index, okay, RVI. So help of the RVI we can also identify for the vegetation area. And if you check the RVI formula, I can see it also help you the different types of crop we can identify. RVI formula. So we need the VV and VS band. Let me show in just a minute. Yeah, this is the formula. You can see this the RVI. It's called the radar vegetation index, RVI. Okay. So when you compute this formula, we can easily get the vegetation, and we can easily identify water and vegetation or dense vegetation. Okay. So if you simply show you the code, it's called the radar vegetation